Right. In the last class, we have discussed about the phasor, how a sinusoidal waveform is represented in the phasor. This is the discussions we have made. Right. Now, in that one, I already told you in the sinusoidal function, sometimes you write a theta, Vm sin theta or Vp sin theta. Sometimes you write a 2 pi omega t. So where omega is angular velocity of the phasor. So when the phasor rotates through 360 degrees or 2 pi radians, one complete cycle is traced out. That already we have discussed in the last class. Therefore, the velocity of rotation is called the angular velocity. So that velocity of rotation we call it as a angular velocity, and it is generally represented with a letter called as omega. So this is omega. So that omega is given by 2 pi into f. So here f is the frequency of the sinusoidal waveform. So, and you please note that the angular velocity is expressed in radians per second. So that is why when you write here sinusoidal expression v is equal to Vm sin omega t, generally we represent it where omega is the angular velocity, and this angular velocity is in radians per second, and if you multiply with the time is seconds, then ultimately you will get the in radians only. So the instantaneous voltage at any point in time is given by this formula. Now let us look at this diagram. Now for this diagram, let us we see this is a waveform. So where you have a voltage waveform, here it is. This is a voltage waveform. And this is a current waveform. Right. Now, if you look at these two waveforms, the phase shift concept or phase lag, phase lead, we can already discussed it. Now, in this voltage waveform, if you carefully observe that the peak value of the voltage the voltage waveform is started at zero. It is started at zero and attains a maximum at this point. The voltage waveform is attaining its maximum at this point. This point may be some angle we do not know, right? But the amplitude of that is given by Vm. The amplitude of that voltage is waveform is given by Vm. That is maximum voltage attained by the waveform. Right. And whereas when you take the current waveform, your current waveform is starting at this point. That means at a uh, angular displacement of phi angle. So at an angle of phi, it starts the current waveform and attains a maximum at this point. And now in this case, if you observe that the maximum value of this is Im, the maximum value of Vm and Im are different. See the amplitudes Vm here it is greater than Im, right? But the voltage waveform completes one cycle in 2 pi radians, whereas your current waveform also it completes one cycle in 2 pi radians only. This gap is also 5. So it is starting with a distance of 5 and it is ending at with a distance of 5. Yeah. Therefore, both are having the same frequency. Therefore, they can be represented in the trigonometric expression like this. Since the voltage waveform is started at 0, so the voltage expression we can write it as V is equal to Vm sin omega t. And whereas your current expression, current expression I is represented as Im sin omega t minus 5. So this negative sign, as I mentioned earlier, is representing that it is lagging, right? Because after a distance of 5 or after an angle of 5 degrees or radians, 5 radians, the current waveform is starting. That means current E is behind the voltage, we can say. So when a quantity is behind another quantity, then we say it is lagging. That is why when it is a lagging, the expression for that waveform we represent with a negative sign here. I is equal to Im sin omega t minus 5. So where we can say that the current lags the voltage. That is it by taking the reference as voltage. Now here the reference waveform here it is voltage. So voltage as the reference, we have considered it. So with respect to that voltage waveform, your current is lagging with an angle of 5. So that is a concept how you can find out the lagging or the phase shift. Now, how do we represent in the phasor? How do we same concept? We deal with the phasors, and the phasor of this voltage and current waveforms are being represented here. Since the voltage waveform is starting at 0, so absolutely it is a reference as I mentioned earlier. So the voltage phasor is drawn like this. The voltage waveform, this is the voltage waveform, is represented as a phasor since it is a reference. And 0 degrees 30, 0 degrees line we have drawn. Now we want to draw the current phasor. So current phasor can be drawn with the amplitude as Im. Im current ఆ phasor యొక్క length must be Im. సో మనం ఇక్కడ వేవ్ ఫామ్ లో చూస్తే మనకు తెలిసిన దాని ప్రకారం Vm ఈజ్ గ్రేటర్ దాన్ Im కాబట్టి ది లెంత్ ఆఫ్ Vm ఈజ్ మోర్ దాన్ ది లెంత్ ఆఫ్ Im. చూడండి ఇక్కడ కూడా అలాగే రాశాను. సో ది లెంత్ ఆఫ్ Im ఈజ్ Im phasor, that is current phasor. The length of the current phasor is less than the length of the voltage phasor because Vm is greater than Im or Im is less than Vm. Now here I have drawn this phasor Im below this Vm. Here it is. In the last class we have discussed that the vectors or the phasors of any sinusoidal waveforms. How do we define the phasor? Phasor is also a vector which has both magnitude and direction, but that vector is rotating. If it is rotating in the counterclockwise direction, if the vector is rotating in the counterclockwise direction, then that vector we call it as the phasor. That is the only difference between the vector and phasor. Now here, since we are drawing the phasors of both voltage and current, they must be rotating in the counterclockwise direction. Now here the voltage phasor we have taken it as a reference like this. ఇలా reference గా తీసుకున్నాం. So and this voltage phasor will rotate or will move in this direction, clockwise, counterclockwise direction అన్నాం కదా. And similarly, if you draw the current vector on the same graph, and that current vector should also rotate in counterclockwise direction in like this. This is also rotating it with the same speed, because what is that speed? Omega t. In both the cases we have. So with the same angular velocity omega, with the same angular velocity, these two vectors will rotate, move in this direction, in counterclockwise direction. So now from this diagram we infer that we came to know that current is I is lagging behind V. అంటే వోల్టేజ్ వెనకాల కరెంట్ ఉంటుంది అంతే కదా. ఎందుకంటే వోల్టేజ్ స్టార్ట్ అయిన తర్వాత 5 యాంగిల్ తర్వాత కరెంట్ స్టార్ట్ అయింది, కరెంట్ వేవ్ ఫామ్. అంటే ఏంటి? కరెంట్ ఈజ్ ఆల్వేస్ లాగింగ్ బిహైండ్ వోల్టేజ్. సో వెన్ టూ వెక్టర్స్ ఆర్ రొటేటింగ్, ఒకదాని వెనకాల ఒకటి ఉండాలి అని అంటే, సిన్స్ ద టూ వెక్టర్స్ ఆర్ రొటేటింగ్ ఇన్ ద కౌంటర్ క్లాక్ వైజ్ డైరెక్షన్, ఈ డైరెక్షన్ లో మన కరెంట్ వెక్టర్ కిందకి డ్రా చేస్తేనే మనకి ఇట్ ఈస్ లాగింగ్ బిహైండ్ ఉంటుంది. ఎందుకు? ఈ రెండు కూడా ఈ డైరెక్షన్ లో మూవ్. ఈ డైరెక్షన్ మూవ్ అయినప్పుడు కరెంట్ వోల్టేజ్ వెనకాల ఉండాలంటే కంపల్సరీగా కరెంట్ వెక్టర్ షుడ్ బి డ్రాన్ డౌన్వర్డ్స్ అండ్ విత్ అన్ యాంగిల్ ఆఫ్ 5. That is why now we'll see the another diagram. See here, yeah. So here also in this case we have two waveforms. One is voltage waveform. This is voltage waveform, and this is current waveform. And if you look at that, I is ahead of V. So this ahead we call it as I leads V అని అంటాం. I leads V. Current I is leading V. So now as usual, see here, if the voltage is a sinusoidal when it is starting from 0, how does we represent them in the trigonometric form? We represent them in the trigonometric form as V is equal to Vm sin omega t. And similarly the current in trigonometric form can be represented I is equal to Im sin omega t plus 5. This positive sign indicates that it is leading. అది ఆల్రెడీ మనం జన క్లాస్ లో చెప్పుకున్నాం. నెగటివ్ సైన్ ఉంటే లాగింగ్ అని గుర్తు. సో కరెంట్ లీడింగ్ కాబట్టి +5 వేసాం. సో ఇలాగ ట్రిగనామెట్రిక్ ఫామ్ లో వీటిని రిప్రజెంట్ చేస్తాం. అండ్ సేమ్ థింగ్ వేవ్ ఫామ్ కెన్ బి రిప్రజెంటెడ్ ఇన్ ద ఫేజార్స్ లైక్ దిస్. So as usual, since voltage waveform is starting at 0, we take voltage phasor as a reference like this. This is a voltage phasor and with a length of magnitude of Vm, and current phasor leading kada, leading అయినప్పుడు కంపల్సరీగా ఇది పైన ఉండాలి. ఎందుకు పైన ఉండాలి? both the vectors ఇందాక చెప్పినట్టుగా both the vectors are running, are moving in the counter clockwise direction. అంటే రెండు కూడా కౌంటర్ క్లాక్ వైజ్ డైరెక్షన్ ఉన్నాయి కాబట్టి కంపల్సరీగా కరెంట్ వెక్టార్ షుడ్ బి డ్రాన్ అబౌవ్ ది వోల్టేజ్ వెక్టార్, సిన్స్ ది డైరెక్షన్ ఆఫ్ బోత్ ఈస్ లైక్ దిస్. కౌంటర్ క్లాక్ వైజ్ డైరెక్షన్ రెండు ఈ డైరెక్షన్లో మూవ్ అవుతున్నాయి కాబట్టి కరెంట్ లీడింగ్ అవ్వాలి అంటే కంపల్సరీగా వోల్టేజ్కి ముందర ఉండాలి అంటే ఈ డైరెక్షన్లో కౌంటర్ క్లాక్ వైజ్ డైరెక్షన్లో కరెంట్ ఫేజర్ షుడ్ ఆల్వేస్ బి above the voltage phasor like this and with an angle of 5. So this is we called as leading. So the leading phasor is drawn like this and the lagging phasor is drawn in that. Now is it clear? And now in this example, the current expression is already given in the trigonometric form. I is equal to 141.4 sin 314t. Generally, a sinusoidal waveform alternating current expression is given by I is equal to Im sin omega t in మనం already చదువుకున్నాం. So now ఇందులో when you compare this equation with the above equation, that is 141.4 sin of 314t, ఈ రెండింటిని కంపేర్ చేశారు అనుకోండి, when you compare both these two, then what is Im? Im will be this. Im is same as this quantity. Right, then Im you will get it as maximum value of current is given by 141.4. Then when you compare this omega t or omega with this one, then what you will get here? Omega is equal to 314, and which is nothing but which is nothing but your angular velocity. And angular velocity, once you know the angular velocity, you have a formula. Angular velocity is equal to 2 pi f. Angular velocity ki formula is 2 pi f in the. So now in this one, omega is already 314 radians per second, and f you find out. Therefore, f is equal to what you will get? F is equal to omega by 2 pi, which is given by 50 hertz. 50 hertz. So this is the second bit frequency, and this is the first bit is over. Then coming to the time period, and in the last class also we have discussed that the relation between the time period and frequency is given by frequency is equal to 1 by time period, or time period is equal to 1 by frequency. Both are inversely proportional, and with that one, once you get the frequency, 1 by 50 will give you 0.02 seconds or 20 milliseconds, you can say. All right, time period is over. Then the instantaneous value when current is when time is 3 milliseconds. What is instantaneous value? Actually, the expression here, the given expression is in only instantaneous value. In the t place row, you put 3 seconds here. Substitute 3 here. These are 3 milliseconds. If you substitute 3 milliseconds here, right, in place of t, then you will get I is equal to 141.4 into sine into 314 into 3 milliseconds got 0.003, and which will be around 114.35 ampere. So likewise, the instantaneous value of this current at t is equal to 3 milliseconds can be determined. Now is it clear?